So in order to find this midpoint, I need to add my x coordinates together. So I'll add the 7 and the -6 together, and then I have to cut that in half. I'll do the same thing with the y coordinates. So I'll take the 0, add the 5 to it, cut that in half. That's really what our midpoint formula looks like when we plug the numbers into it. So we end up with, if I simplify this down, I get 1 over 2 and 5 over 2, and again I would just leave that as the ordered pair for that one. In order to find the slope, I have to use my slope formula. So in order to do that, I do my y's on top. So I'll start with my -6. I'll subtract the -3, so that's really a +3. And then since I started with -6, I have to start with 5, and then I'll subtract the 1. So that will equal really my slope, so a -3 over 4. And there we go. If you can reduce it, of course you want to do that. Here we have to find the slope of the line and sketch the graph. If you need to, you can put this equation in slope-intercept form to graph it, or find the slope. If you remember though, for standard form, the slope is the opposite of a over b. So in this case, the slope would be -3 over -4. So in other words, just a regular 3/4 for the slope. So that's the slope. It looks like I won't really have a nice y-intercept here. I don't necessarily like working from those not nice points, so I would probably just try to take a look at coming up with a table of values. And I really just need one nice point. I don't need any more than that. I'm trying to look at how I can make the 3 and the 4 together to make a 1. Well, I know they have a difference of 1, but I kind of need to flip that around. I need x to be a -1, so I'd have a -3, and y to be a -1, so that I would get a +4. So 3 times the -1 would be -3, minus 4 times the -1 would really be +4. So -1, -1 being a point on my graph. So we'll put that in here. And then I already figured out that the slope was 3/4, so up 1, 2, 3, to the right 4. So we get to the point 3, 2. So again, I can double check and make sure that I'm going the right place. So if x is 3, y is 2, that makes sense because then I've got 9 minus 8. So that works out. And again, I can continue with my up 3, right 4 pattern to get some other points. I can also go down 3, left 4 to get to some points there. Do our best to connect that with a line, arrows on both ends, and that's what that looks like. In order to write the equation for this line in slope-intercept form, I would start with point-slope form. So it'll look like this: y minus 5 equals my slope, -6 times x minus a -4, so it's a +4. I would have to distribute the -6 through those parentheses, so I get a -6x minus 24. Make sure we get the negative to go all the way through. And then from there I just have to add the 5. So that's not too bad. So we end up with our answer being y equals -6x minus 19. Here they just give me the equation and ask for it in slope-intercept form. So I'd probably begin by subtracting the 12x from both sides. First, make sure you don't combine the 12x and the 12. 2y equals a -12x plus 12. So all I really have to do then is divide both sides by 2. That gets me y all by itself, so we end up with y equals -6x plus 6. And that's the equation that we're going for. Here we're looking to write the equation line passing through the 2 points. We are asking for the equation in standard form this time. So I would start with writing the equation in slope-intercept form and then manipulate it to get to standard form. Let's see, so first I need the slope. So I'm going to start with my 2 minus negative 3, so it's really plus 3, over negative 4 minus 7. So I get 5 over negative 11. So that's my slope. Again, actually, I'd probably start with point slope then, and I think I'm going to use the negative 4, 2 point. So that becomes y minus 2 equals negative 5/11 x, and then plus 4. So we'll be a bit of a pain dealing with these fractions. One thing I could do, since I'm going for standard form anyway, is I could decide to multiply both sides of the equation by 11. Doing that will take care of those fractions for me. I end up with 11y minus 22 equals negative 5 times x plus 4. And again, the x plus 4 does not get multiplied by the 11. It's not a distribution. It's just three things being multiplied together. So I can multiply the first two together and then the third by the result of that product. So from there I get the 11y minus 22. Now I can go ahead and distribute the negative 5. It's a bit easier, so negative 5x minus 20. And again, still going for standard form, so I want the numbers to be on the same side. So I would add the 22. So I end up with just 2 on the right side. I can also go ahead and add the 5x. Of course, that won't actually combine with the y's, but it will give me my answer, which if we write the x's first, 5x plus 11y equals 2. And I understand dealing with fractions can be tough. You can do that a number of different ways. Use your calculator to help if you need to. So here we need to write the equation line that goes through negative 6, 5 and is parallel to the equation here, negative 7x plus 5y equals 57. They do want the equation in slope-intercept form. I would begin, like we did earlier, with just getting the slope from the standard form, so the opposite of a, so a positive 7 over b, which is 5. So now I just have to write the equation for the line that goes through negative 6, 5 with a slope of 7/5, and I would do that in point slope form to begin with, so y minus 5 equals 7/5 x plus 6. Now since I am going for slope-intercept form, if I were to get rid of the fractions, I'm going to have to bring them back anyway. So I'm just going to go ahead and use the fractions. So y minus 5 equals 7/5 x plus, and again, have your calculator help you with this if you need to, but 7/5 times 6 is 42/5. Then we can go ahead and add the 5 to both sides. Again, use your calculator if you need help with coming up with the sum of 42/5 and 5. The way that works is in terms of fifths, 5 is 25/5, so 25 and 42 makes 67. So we get 67/5 for that one. So we have the same type of problem here, but now we're going perpendicular to negative 5x minus 2y equals 27. Of course, the slope for this one would be 5 over negative 2. So the perpendicular slope would flip that over, and then it would become positive. So the slope we're actually using is 2/5. So now I'm just writing the equation really of a line that goes through negative 5, negative 2 and has a slope of 2/5. So I'll use the point slope form again, so I'll go y plus 2 equals the slope 2/5 times x plus 5. So it'll look just like that. Distribute the 2/5 and then subtract the 2, and we'll be all set. So 2/5, oops, I don't know why I wrote that upside down. So 2/5 x plus 2. Oh wow, subtract the 2 and look at that, we get a y-intercept of 0, so it's just y equals 2/5 x is all. So there we go. In order to graph this compound inequality, I would recognize that the 3x minus 2y equals 6 for the boundary line would have nice x and y intercepts because 6 is divisible by both 3 and negative 2. So I would start with those points, and if I need to find more, I can do so using the slope that I can figure out between those two. It looks like 0, negative 3 being one of those points, and 2, 0 being the other. So up 3, right 2. So I can plot another point over here. Again, they look like they line up. This one is a solid line. And again, in order to figure out where to shade, you can use the origin to test. If you plug that in, you get 0 is less than or equal to 6, which is true. So I'd look at it as shading this way. And that's about it. Again, you can also look at the x and y values, though. So x is positive, and it's less than the 6, so that would be going on this side of the x-axis. Y is negative and less than the 6, so that flips around, and y would be going up the y-axis. Now, all that stuff is really saying the same thing, so just different ways to do that. For the second inequality, I would add the 1 and get x is greater than 1. So it's really going to be a vertical line, so the boundary line x equals 1 is dashed because the inequality does not have the equal to. And really those values of x that are greater than 1 are going to be the things like the 2, the 4, the 6. Those are greater than 1, so this one would be shaded on this side. They will overlap in this area here, so that's the part that we're looking to shade, is that region. In order to graph this system of inequalities, the first one, easy enough to subtract the 3x and get the slope-intercept form, so I may as well use that. So a y-intercept of 3 and a slope of negative 3, so down 3, right 1. And I could continue that going down 3, right 1, so that's pretty good there. Do my best to draw a line through those points. Again, if I use the x and y, they're both greater than the numbers, so that would be up the y-axis and up the x-axis. If you look at the origin would make it false, 0 not greater than or equal to 3, so the origin on the unshaded side. So again, those things should all agree with which side gets shaded. For the other equation, I can see the y-intercept is not going to be a nice point, but that the x-intercept is. So I'd make my table, plug a 0 in for y, figure out that x equals 1. So 1, 0, also a point on that line. And I can look at the standard form and figure out that the slope for that is 1/4. So again, the negative 1 over negative 4, which simplifies to be 1 over 4. So I could go up 1, right 4. In order to find some other points, I can also go down 1, left 4 to get another point over here. I can already see where they cross, so I'm going to say that's good enough for my line. Put my arrows on both ends. The green line, now, x being less than the 1 and x is positive, that would tell me to the left of the x-axis. Now y is negative but less than 1, so that one goes up the y-axis. Now again, those do agree. So green one shaded on this side of the line. The blue one, again, shaded on this side. So the part where they overlap is between these two here, so that would be the shaded region. Here we can decide that the relation is not a function pretty early on. We've got negative 9 going to 3 and negative 9 going to 5. So not a function for that one. And we're also looking here to decide whether or not this is a function. So I've got a negative 1, a 1, a 5, an 8, and a 10. So nothing repeats there as far as the x values. So that is a function. So with 13 and 14, we need to say whether whether the relation defines y as a function of x. This one is a function. Again, what we're looking for to say if it's not a function is if you had y equals plus or minus something. They also want the domain for this function. The domain is going to be limited here because we're square rooting 4x minus 3. Can really only take the square root of a non-negative number to get a real number result. So I set my radicand, 4x minus 3, greater than or equal to 0. Solve that inequality by adding the 3 and then dividing by 4. So x has to be greater than or equal to 3/4. That describes my domain. Now, of course, we prefer interval notation, so 3/4 to infinity is what we're looking at for the domain there. When working with something like x times y equals 5, we really should solve for y first. So we would divide both sides by x to get the y by itself. So we get y equals 5 over x. That is a function. Again, we don't have the plus or minus. We got the y all by itself. The domain is going to be limited. Now in this case, we can divide by negatives, we can divide by positives. The only number we cannot divide by is 0. So since our denominator is really just x in this case, x equals 0 would be a problem. We don't want x to equal 0. So in our domain, we describe that in integral notation by saying everything from negative infinity up to 0, but not including it. And we do that with the union of everything starting at 0, but not including it, up to positive infinity. So really, if we just kind of cut out the middle there, it's everything from negative infinity to infinity, just not 0. So given function notation, we're going to find g of a minus 1. So really what we're doing there is replacing x with a minus 1. So instead of 2 times x, I have 2 times a minus 1. And so I've got the 2 times a minus 1 minus 5. So again, the g of a minus 1 is not going to change on the left side, so I'm just going to leave that alone for a bit. Figure out my right side here, so 2a minus 7. That's really what g of a minus 1 equals. This system is really set up to use substitution. It tells me x is 21 minus 5y, so I'll replace x in the second equation with that value. So I have 9, and then 21 minus 5y plus 4y equals negative 16. I do have to distribute the 9, so 9 times 21, that would end up being 189 minus 45y plus 4y equals negative 16. Combining my y's on the left side, I get 189 minus 41y equals negative 16. I would probably subtract the 189 from both sides. So I get negative 41y equals 205, of course, negative. And then just divide by the negative 41. So I find out that y equals 5. Once I know that y is 5, I can plug that back into probably this equation for the 5 to find x. So 21 minus 5 times 5. We get 21 minus 25. So x is a negative 4. And again, you can write that answer as an ordered pair, negative 4, 5. For this system, I would recommend using the elimination method. I see I've got a minus 5 on top and a plus 2 on the bottom for the y's. So if I multiply this entire top equation, so if I multiply the top equation by 2, that'll give me a negative 10 on top. Multiply the bottom equation by 5. I'll get a positive 10y on the bottom. So top equation becomes 14x minus 10y equals negative 84. Bottom equation becomes 25x plus 10y equals 45. Now when I add those together, I end up with 39x equals negative 39. So that works out well. I divide by the 39. Found out that x is negative 1. Once I know that x is negative 1, I can use that to find y. I can plug it into either of the first equations. I'll choose the second one. So 5 times negative 1 plus 2 times y equals 9. So negative 5 plus 2y equals 9. Add the 5 to both sides, I get 2y equals 14. Then divide by 2, I find out that y is 7. Again, I can write that as an ordered pair, negative 1, 7.